Well, hey everyone, and welcome back. In this video we're talking about unconformities and the three most basic types of them. So first and foremost, it's important to actually define what an unconformity is. And similar to a fault, it's a non-depositional feature it is an erosional feature, results from erosion, and essentially what it does is it marks a time in which the sequence of deposition of layers of strata on top of one another was inconsistent. Okay, so those are the three big parts of the definition I wanted to cover. I'm not going to draw anything out just for a general unconformity, but as we get into the types of unconformities, you'll see what I'm talking about. Oops. So as I said, there are three types we want to cover today, and the first is actually not a non-conformity. The first is a disconformity, which is the most simple type by far. It's incredibly simple to understand. Actually, most of these are pretty simple, but what a disconformity is it's just a break in the deposition of sedimentary strata that is shown by the erosion of one layer followed by the deposition of another. So how that looks is if you've got, we'll just put some strata here, and then let's say we've got this strata right here. Now the one up here has been eroded, so it's got maybe some rough edges, maybe some dips in here. And then we have our surface layer deposited on top. And we'll label those A, B, C, and D. Well, it looks similar enough to just flat deposition on top of one another, but you can't ignore the erosion that has occurred at this line that makes it appear so ununiform. And because of that, we can say that erosion occurred in between the deposition of these two layers, and therefore this is a disconformity. So to summarize that, a disconformity is just when you have a layer of sedimentary rock that is deposited, in this case that was B. B was deposited, and then that layer of sedimentary rock is eroded. B underwent erosion. And then another one was deposited on top of it, such that the look is no longer straight, uniform, just flat beds on top of one another. That's why they're called unconformities. They make strata that doesn't conform with any sort of just straight, nice strata lying down on one another. And that's all there is to disconformities, really. The next one is similar, but different in a key way. It's called an angular unconformity. And once again, we're dealing with sedimentary rock when we look at angular unconformities. And there's a key event that occurs in here. So I'm starting from the top this time. And let's just say we've got strata A here. Right? And then down here, all of a sudden we've got diagonally facing strata, a whole lot of it. We'll call it B, C, D, E, F, G. And you can see I didn't draw the erosional surface here simply because it's not necessary, really. Because when we look at this, we see, well, we had a whole bunch of folded layers here. Maybe they were originally coming up to a syncline, maybe they were going, or an anticline this way, or down here to form a syncline. That's not really important. What's important is that these layers underwent pressure and they are now folded such that they're tilted at an angle. And because of that, the whole thing should be angled. If A was deposited on top of an angled surface, well, it wouldn't just be flat on top of that. That would make no sense, right? So because of that, we can say that, well, there must have been some erosion that occurred on the top of all these layers of rock, such that they gained a flat surface and A was able to be deposited horizontally on top of them. And that's all an angular unconformity is. So if you see flat strata directly on top of tilted strata, then you've definitely got an angular unconformity. Okay, there's one final one to cover, and its name is pretty similar to disconformities, excuse me. I mix these two up a lot. They're incredibly similar. Yeah, you heard me say it just then. But before we had a disconformity, which is with sedimentary rock, right? Well, this final one is called a nonconformity, which annoys me so much because they're incredibly similar. Disconformity, nonconformity. I think they should have given these more clear names, but I have no really special or useful way of remembering which is which. If anyone could come up with one, they'd be probably somewhat of a genius, but a nonconformity is unique because it has to do with igneous rock. Remember that. Nonconformity is igneous. So once again, I'll start from the top, and we'll say there's our surface layer. That's it. And then below it, what has to happen here is we have an igneous intrusion, right? So, before I've drawn dikes, and those are usually more uniform, but let's just say we got this nasty, pluton down here. And that's just igneous rock. That is igneous. Well, of course, there's got to be something in here. So let's just say we have something like this, where we've got a layer there, a layer there, a layer there, and a layer there. And we'll call those B, C, D, E. And there's a little F down there. Well, when we look at this, you could say two things, and actually that was kind of unintentional, but you could just say this was an igneous intrusion, and by the law of cross-cutting relationships, this has to be younger than these because it came up and passed through them. However, you could also say that the igneous rock sort of formed here, and then these were deposited on top of it as it was eroded. So yeah, I guess my picture isn't the clearest, but if you're dealing with the topic of unconformities and you see strata deposited on top of an igneous intrusion, then you know it's a nonconformity. Nonconformities are igneous rock. And that's all there really is to it. They're incredibly simple, just pretty much noticing areas in rock where it looks like, hey, something happened here. It wasn't just deposition upon deposition, whether it be slight unevenness in the lines between them, whether it be completely different angles, or whether it be, hey, this is an entirely different type of rock here. Those are the three simplest kind of unconformities. I will be doing a video on more complex kinds, but for now, hopefully this was informative, otherwise good review. Hope you enjoyed, and I will see you next time.